Go to y equals, and can you see me? Okay, and we'll type that in. So you're going to go x to the third plus 2x squared minus 3x minus 2, and we're going to graph that. All right, we're looking for x-intercepts. Well, what's true about an x-intercept, y equals 0. So before we do a lot of hard work, we can go look at the table. And, well, before we do that, notice that you can see -1, -2, -3. So it doesn't go any bigger than -3. So let's go look. At -3 it's 2, and at -2 it's 4, okay? So let's use a tip here. Since this one is negative and this one is positive, that tells you that there's a 0 between, and I want you to write this down because it makes your calculator so much easier. There's a 0 between -2 and -4, so that's where x is -3 and -2. So you know there's a 0 between -3 and -2. How do you know there's a 0 here? Because y changes sign. You can see y changing sign. Let me show you how that's a big help. So you want to find the 0. So we go second calc. Tell your calculator number 2 that you would like a 0. Now, left bound, we already figured out the left bound. Whoops. The left bound is -3, so instead of scrolling around on this, you just tell it -3, enter. Now it says, what's the right bound? Right bound is -2. Enter. Guess. Yes, you wanted to guess. And so there's your 0. -2.814. When it says the word intercept, it wants a point, so you need to write the point down. I'm going to show you again on the next two zeros how that helped me, how I knew to punch in -3 and -2. So let's go second, calc. You need to find a 0. Now, before we do that, let's go to table. Let's see where the next 0 is. Any place that you see y change sign, you know that there's a 0. Let's look at y. Because y is positive up here and negative down here, so if y changes sign, you had to cross that x-axis, okay? That's how I know there's a 0 there. So right here, where y changes sign, right there, let's look at what that is. So that's from -3 to -2. That was our first one. Let's look for the next one. Right here, y is positive, now it's negative, so that occurs between -1 and 0. What that does is it gives you your left and right bound without having to look and scroll. So now second, calc, 0. And left bound is what? -1. No more work on your part. Right bound is 0. And you hit enter. Should you guess? Yes, you should. And that is -0.529. Yes, we want 3 decimals. No less will do. And your last one. Now you can see that it's between 1 and 2. You can see it's crossing there, but let's do our table test. And let's hunt for it. Now y is negative. When does it change? Oh, right there. Y changes from negative to positive. That's between 1 and 2. Well, you could see that with your eyes. But I really want you to utilize the table. It's one of the most unutilized tools that really helps you out a lot. So now second, trace or calc. We want a 0. And what's a left bound? Well, you know it's 1. Right bound is 2. And it really speeds up your work. So that's 1.3430. And the y-intercept, y is always easy to find. Basically, you're plugging 0 in for all these x's so you can see that it's -2. Also, let me show you your calculator. Go to second table. All you do is look where the x is 0. Wherever x is 0 is your y-intercept. Y-intercept is always easy to find. It never requires a lot of work like the x's do. Okay, increasing intervals. Ooh, I'm going to draw a quick sketch. Go to your graph, and you know that it looks something like this, right? So where was this thing increasing? It was increasing here and there. That's increasing. So what is this going to be? We know it's -infinity. Where does it stop increasing and change? Well, notice it stops increasing and starts decreasing at a very special point. What's that special point called? A vertex. And now it's decreasing. When is it going to stop decreasing and start increasing? At the vertex. That's why we like to consider a vertex occurs where we change. So what point am I going to ask my calculator for? You got it. I know you said it. Max here and min here. So again, on your calculator, go to second calc, maximum. And again, this one you can visually look with your eyes. 1, 2. You know the max is between -3 and -1. So you can tell it -3, -1. You don't have to scroll all over the calculator. There's the maximum. So from -infinity all the way to here, which is -1.869. And then where else is it increasing? Right here, we need the minimum. So we'll go second calc. I'm going to write max down in case we need that point. And I want you to see the relationship if later on you're looking at your notes. You're like, how did she know that? Well, it comes from the maximum point or the minimum. Remember, we always change from increasing to decreasing at a max or a min. That becomes important later when we start talking about points of inflection. So second calc. This time I want the minimum. I want the bottom. And I'm going to go. Now, I showed you how to do it with numbers. If you are a scroller, you just scroll close to it and hit enter. Then you go around this way and hit enter and enter. And there you go. That works too. So minimum is 0.535, -2.879. So use your calculator. Make sure that you are following along and really punching these in and not just copying my answers down. Okay? All right. So it's increasing from this x value to infinity. What's this x value? That x value is what? 0.535 to infinity. Now decreasing, it's decreasing right here. And that's going to be from this x to this x. What was this x value? -1.869 to 0.535. And you know what I did? I did a bad thing. I didn't put my brackets there. Let me be careful about that and meticulous. Don't let me get away with that. Okay. Constant intervals, there's none. And then it asks for the vertex. Well, we already found that, so we're not going to do that work again. My minimum was at 0.535, -2.879. And my maximum was at -1.869 for is that 065 that I wrote down? What did I write down? I can't read my own writing. Oh, that's -1, right? No, 4. See, this is bad when you can't read your own writing. Okay, the domain on this thing, it goes to the left forever, it goes to the right forever. The range, this is an arrow going down, so it's -infinity. Well, how do you like that? There we go. And to positive infinity. Remember, again, keep reminding yourself what range is. Bottom to top. You cannot go backwards with that. Domain is left to right, and you cannot go backwards on that. Symmetry, even or odd. Well, let's look at this graph. Does the y-axis cut it exactly in half? No, so it doesn't have even. Pay attention, we got a hill over here in the second quadrant. If I turn, and it's way up here, if I turn it upside down, does it look exactly the same? No, it does not look exactly the same. So I have no even symmetry. I have no odd symmetry. I don't have any symmetry at all. And then I've got a question that I'm posing to you here. For a function, can we ever have two y-intercepts, y or y not? Well, let's think about it. Can you ever have two y-intercepts? No, you can't. I want you to tell me why tomorrow, okay? All right, last one. We're almost done. You're doing great. And one thing I'm going to ask you to show me tomorrow is I'm going to ask you to show me something you did in your notes that personalized them for you. Maybe you colored certain things yellow. Maybe you put stars on important things, but these are your notes and you're going to need them, so I want to see what you did to make them look good for you, okay? Last thing, equation of a line. We did this last time, so I know you're going to be fast. Our equation is y minus y1 equals m times x minus x1. I'm going to do the first one with you, and I'm going to leave the second one with you as your challenge problem to do for tomorrow. Now here's the trick. Back when you were a youngling in last year, we gave you points. This time we give you this funny looking stuff. What did I just give you there? What does that notation mean? Well, this is the same thing as finding a point. Remember, this is an x, and this is like saying f of x equals, so that's the same thing as saying y, so there's your y value. So this is a fancy pre-calculus way of giving you a coordinate point. -3, -5. And this one is 1, 2. So I'd like you to take a minute and find the slope. I'm going to do it my easy, lazy way. I'm just going to think instead of doing a whole lot of calculations. Slope is rise over run. So which one is rise, y or x? Of course it's y. So if I was at -5 and I traveled all the way to 2 on a number line, how far would I go? Well, -5 to 0 is 5, and then 2 more is 7. So -5 to 2 is 7. If you'll think about it this way, instead of plugging it into a formula and subtracting, it should help you eliminate errors with negative signs. It's really easy to say, oh, 2 minus 5 is 3, instead of 2 minus 5, -5 is 7. So I always think, how far did I walk? If I